So in this last section of Unit 11, we're going to be learning to perform operations using scientific notation. So let's write the word notation right here. And the warm-up that we're going to start with is maybe not so much of a warm-up. It's a good review of some of the skills that we've learned for working with exponents, but there's also some really important properties that we need to understand when we're working with negative exponents. So there's some more good practice right here. So don't just tune this out. Make sure you're paying attention to this. So as we take a look at these, some of these I'm going to do in more than one way because there is more than one way, and I'll show you what I think is the easiest way to think about these. So on this problem right here, this is pretty straightforward. We're going to multiply the coefficients together. So we get a 5 times 6, that's a 30. We've got a to the second times a to the seventh. Technically the rule says that because they have the same base, we're going to add those together. If I've got 2 here and 7 here, then I've got 9 of them all together. So we want to go ahead and write down that answer. Either way you want to think of it is fine. And then let's take a look at the next one. On B, it says 10b to the negative 2, or sorry, negative 1 times 2b to the negative 4. Now we've got a negative exponent on this. I want to show you what I think is the easiest way to do this. I think it would be easier to follow that general rule that we don't like working with negative exponents. So I'm going to write this as 10 over b to the first times 2 over b to the fourth. You'll notice again we've got a negative in the exponent. It only applies to what it's over. So the 2 is just fine and the 10 are just fine. It's the b's that move down into the bottom. And then when we multiply here, we get this. We get a 20 on the top. There's 1 b here and 4 more b's here, so that would be b to the fifth right there. Now that works just fine, but it is possible to do the same problem a different way. Let's multiply these together and we get 20, and then I could say that it's b to the negative 1 plus negative 4. So this is just saying, hey, these have the same base, so we're going to add the exponents together. So this would be negative 1 for the exponent of the first one, add the negative 4 for the exponent of the second one. So this would be 20b to the negative fifth. Negative 1 plus negative 4 would be negative 5. So then we just change this and say, okay, I'm going to change the exponent from the top to bottom to take care of that reciprocal idea that's introduced by the negative exponent. You get the same answer either way. I do think it's easier to think of it this way. So again, I'm going to do the same thing on the next one. So I'm going to go ahead and do it in what I think is the easiest way to do the problem. So that's going to be this. I'm going to go ahead and reduce that. That's going to be a 2. And then I'm going to write the a to the 7th on the top and the a to the 12th on the bottom. Now we've got positive exponents. We can do it like we normally would. There are 7 on the top and 12 on the bottom. I'm going to cancel those 7 with 7 of those, so that's going to leave 5 here. So we end up with a 2 on the top and an a to the 5th on the bottom, and we're done. If you wanted to do it the other way, here's what you would do. We're going to go ahead and cancel these, so that's going to be a 2. And then the quotient rule for exponents says this. We're going to subtract the bottom one from the top one. So this is going to be a to the negative 12, subtract the bottom exponent, so that's going to be negative 7. So that's going to be a 2, and then this is going to turn into a plus 7 because negative times negative is positive, and that's going to be a to the negative 5th. The negative in the exponent means reciprocal, so we'd move that into the bottom. And there we go. So you'll notice what we've got here is the same answer. I do think it's easier going this route. So let's take a look at the last one, and I'm just going to do this one way. I'm going to go ahead and simplify the numbers. So 2 goes in here once, goes in there 4 times. So there's a 4 left on the bottom, and then here's what I'm going to do. I'm going to move this so that it's on the top. So this is going to be an x to the 4th for this for the top one, and then an x to the 4th for this one, because we can move from bottom to top or top to bottom. Remember, this means reciprocal. So reciprocal means we're going to flip it over. So if it's in the bottom, we can move it on the top. If it's on the top, we can move it in the bottom. Like we did over here. So this would be x to the 8th over 4, and we would be finished at that point. So it's a little tricky working with those negative exponents, but it's a really good thing. I do want to just show you really quickly that you could also write it this way, just so you're familiar with this. We could write that as a 1/4 x to the 8th. That's got a coefficient out front. So either way there is fine. There are a lot of people that forget that you can do this, so I do just want to show you that really quickly right now as a review. Okay, let's remember those rules for working with numbers in scientific notation. They've got to be written in this particular form. It's going to be m times 10 raised to the n. And the first part of this is the decimal number. So m must be a decimal number. So let's write the word decimal right here with only one non-zero digit in front. Okay, so it's got to have a number digit 1 through 9 in front of that decimal. okay, in front of the decimal. Okay, so to perform operations in scientific notation, we just need to remember a couple of things. It might sound like, oh my gosh, scientific notation was hard enough, let alone doing operations, but it's actually not too bad. So we just need to remember these rules. The product rule for exponents, remember we add the exponents when we're multiplying. Quotient rule for exponents, we subtract the exponents when we're dividing. And the answer always needs to be written in scientific notation. So that's this stuff up here. So what we mean by that is, let's say we got an answer like this, 39.2 times 10 to the fifth. Looks perfectly respectable, looks like we're in great shape. But remember, this decimal number has to have only one digit in front of the decimal. So right now we've got two non-zero digits in front. So we'd have to move this over, and then we'd have to compensate here. So 3.92 times 10 to the, and then remember, if we're making this smaller, we need to compensate by making that bigger. So we would add 1 and raise that to the sixth power. So that's the basic idea. We can essentially treat every problem below as two separate problems. So the first thing we're going to do is we're going to perform the operation on the decimal numbers. And the cool thing about this is you can use your calculator if you need to here. And then second, perform the operations on the powers of 10, making sure that you write the exponent on the top, even if it means having a negative exponent. What we mean by that is you're going to run into some problems where we've got division. And you may look at it and think, gosh, we were always used to having positive exponents. I need to write it on the bottom to make it positive. That's not true. We want to make sure that it's written on the top. In fact, I'm going to put a little star by this, even if it means having a negative exponent, because unlike with other expressions in scientific notation, we know exactly what that negative means. It means we're dealing with a teeny tiny number. Okay, and the last thing you need to do is you need to make sure that your final answer is written in scientific notation, like we mentioned up above. This guy right here would not be acceptable. This one would. We've got to make sure that our answer is written in scientific notation. So let's talk about how to do this using kind of this two-step process. So the first thing we're going to do is we're going to perform the operation on the decimal numbers. So we're going to do 3.5 times 4. Now, if you know what that is, that's great. If you don't, grab your calculator, pull it up, and let's see what we've got here. So I've got it up on the calculator. 3.5 times 4 is 14. So we get 14, and then times, let's do the power of 10 part. I've got 10 to the 7th, 10 to the 5th. I've got 7 tens here and 5 here, so this is going to be to the 12th power. Now again, notice you might look at this and think, wait a minute, how come you can just move those around and do them separately? The reason is this is all multiplication. It's this number times this number. Every single thing in here is multiplication, so that's the commutative property of multiplication. Let me just quickly mention, if you can do something like this, 2 times 3.5 is 7, and then we just double 7, we get 14. That might make it a little bit quicker to get the answer mentally. Now let's take a look at the answer. We've found the decimal number. We've performed the operation with the powers of 10, and we're multiplying these, so we added the exponents, so we get 10 to the 12th. Then we have to look at it, and we have to make sure that our answer is written in scientific notation. So this is not in scientific notation because the decimal is right there now. So here's what we're going to do, and I'm going to change colors. We're going to move this over one place. So we went from 14 to 1.4. So what we did is we made this smaller. We made the decimal number smaller. If that's the case, then we need to compensate by making this one bigger. So we're going to add 1 because we moved it over one place. So this is going to be times 10 to the 12 plus 1. Again, make sure you just go ahead and write down the plus 1 or minus 1 or whatever it happens to be, and then look at this number, especially when this original number, like the 12, if it were negative, we'd have to be really careful there. So this is to the 13th. So I'm going to go ahead and circle this. That is the answer. Okay, let's take a look at another one. We're going to multiply those decimal numbers together. So I'll pull up the calculator, just multiply those together. So we're going to have 2.7, and we're going to multiply that by 5.2. Whoops. Times 5.2. And we end up with 14.04, so 14.04. Then we're going to have times 10 to some power. So we're multiplying these together, so that means we add the exponents together. So I have a negative 7 plus 9, so that's going to be 2. Now we're almost done with this, except for this is not in scientific notation. We're going to move this over one place. So if we move it over one place, we've got 1.404 times 10 to some power. Again, we made this one smaller, so we're going to make this one bigger. So if we make it bigger by 1, by the number of decimal places that we moved, we're going to add 1, so we're going to get to the third, and we're all set there. Okay? Next one. Let's take a look here. We've got a division problem. So let's see what we've got. This is 2.4 divided by 1.2. You might know what that is, but let's just check. 2.4 divided by 1.2. Should look familiar. That's going to be a 2. So we've got a 2 right here, and then times. Now you can do this two ways. You can move this up on the top, which I'll do in just a second, or you can say, look, I need to take the top one and subtract whatever the bottom one is. So that's going to be that's going to be a 7 minus a minus 4, which is going to be a plus 4. So that's going to be times 10 to the 11th. Or you can do this. You can say that's 10 to the 7th, and then if we move this on the top, that's going to be 10 to the 4th when we move it up there. Either way, that's going to be 7 plus 4, so we end up with 11. Now take a look here. The decimal is right there, so that is in scientific notation. I'm going to make that a little bit more clear by doing a 2.0 times 10 to the 11th. Circle that, and that's the answer. Next one. We're going to do 7 divided by 10. Now, if it's 7 divided by 10, you should know that that's 0.7, 7/10. Okay, if you want to throw that in the calculator, you can. I've got 8 tens on the top and 2 on the bottom. That means 2 of these are going to cancel with 2 of those. So that's times 10 to the 6th. And then this is not in scientific notation, so let's check and see here. If that's not in scientific notation, we've got to move the decimal over this way. So I've got to move it over here. So I've got like 7.0 times 10 to some power. Now remember, we just made this bigger. So we need to make this smaller. So if we move that over one place, we've got to make this one smaller. So we're going to subtract 1, so that would be to the 5th power. And there's our answer right there. Next one, let's multiply those guys together. So definitely a calculator problem. 3.15 times 6.2, 19.53. So 19.53 times 10 to some power. Let's see what we've got here. We've got a -5 and a -9. So -5 minus 9, or let me write it this way, -5 plus -9. That's still going to be a -9, so we're going to get -14 here. Okay, so let's see. I need to make this a little smaller, so we're going to do 1.953. If we made this smaller, we need to make this bigger. Now if we make this bigger, we're going to add 1 to it. Now it seems a little bit weird, but when you add 1 to it, -13 is bigger than -14, and there we go. There's our answer. So let's take a look at this last one, and then I think we've got a couple thought questions here. This one's kind of interesting. We've got 2.2 divided by 8.8. I'm hoping that that looks kind of familiar and you could figure out what that is. 2.2 divided by 8.8, we end up with 0.25. So this is 0.25. Times 10 to some power. Now again, we're going to subtract the bottom exponent from the top, so that's going to be 10 to the -6 minus 5, so that's going to be 10 to the -11. Another way that you could do this is you could cross it off from here and say, look, if I just move that onto the top, it would change the sign of the exponent. So this would be a -5. So we've got -6 of them and another -5 of them, so we have -11 of them. Now I'm going to change colors here just to emphasize again. I did this with the first one over here. Right here, this is not in scientific notation, so we need to move this over one place. So we're going to write down 2.5, and what we did here is we made this one bigger. If we make this one bigger, then we need to make this one smaller. And again, when we say smaller, what we mean is subtract 1 from it. So if we're going to make this smaller, then we need to subtract 1 from it. A lot of people will just look at this and they say, oh, 1 smaller than -11 would be -10, and it's not. We do -11, make it smaller by 1 by subtracting 1, so this is times 10 to the -12, and that's what we'll circle for the answer. Okay, that's how we work with operations in scientific notation. You'll notice that we've kind of followed all the rules there. We did use these rules for products and quotients. We always wrote it with the power of 10 on the top. We never wrote it in the bottom, even though we got several that had negative exponents. No problem there. Now let's take a look at this. Which numbers in D through F are the smallest and which one's the largest? Okay, so we're just taking a look at the answers right here. Which one is the smallest of D through F? Well, the one that's the smallest would be the one that had the biggest negative exponent. So that's this guy right here. So 1.953 times 10 to the negative 13, because it's got the biggest negative exponent. Which one's the largest? Well, ones with positive exponents are always bigger than ones with negative exponents. So the biggest one here would be 7.0 times 10 to the 5th. And again, I put the 0 right here. You don't have to. If you just wanted to say 7 times 10 to the 5th, that would be fine. And the next question is, can all these be done on a calculator? Well, the answer to that is yes, but I'd really like you to practice doing it this way. We may take a look at one in a few minutes. The answer here is yes. And let's take a look at number 20 on your assignment. So I've got the assignment up here. Let's go ahead and take a look at number 20. You can see the type of problems that you'll be asked to do. Here's number 20. So there are a couple of things that you notice. We've got two scientific numbers in the denominator. We've got a set of parentheses, which we usually reserve for multiplication, but that is what it means on the bottom. We've got this big long fraction bar, so we probably ought to figure out what the bottom is and then go ahead and do the division represented by the fraction bar right here. So let's go ahead and write it down this way. We're going to write the 6.48 times 10 to the 5th on the top, and then we'll go ahead and multiply these numbers together. We just treat this like a regular old scientific number problem. So I'm going to clear this off. I'm going to do 2.4 times 1.8. Go ahead and hit enter. We get 4.32, so 4.32 times 10 to some power. Let's see what that power is. We're multiplying these, so we'd add the exponents together. So I'd have 4 add negative 2, so that would give me just 2 of them here. And then we'll figure out what we've got on this part. So we've basically turned it into one of these guys here. So let's do the 6.48, and we're going to divide that by 4.32. See what we get there, 1.5. Okay, so that's not too bad, 1.5. We like that because we know that's already in scientific notation. Now we just need to figure out what the exponent is. There are 5 on the top and 2 on the bottom. That means 2 of these are going to cancel with 2 of those, so I'll subtract there. So that's going to be to the 3rd. And again, the cool part about this is already in scientific notation. We don't have to change this at all. All right, good luck on your assignment.